Our lesson for today, we are going to look at chemistry 1501, that is general chemistry. Today we'll be looking at the tips on how to calculate the pH of a solution to determine whether it's basic or acidic. Let us start. This equation, we use it to calculate the pH scale of a solution. Now, what we actually need to use this equation, we need the concentration of the hydronium ion that is produced by an acid. Sometimes instead of H+, you will see something like this, hydronium, which is similar to this. Actually is the same, because you know that an acid either produces hydrogen ion or hydronium ion. And then we also have this equation whereby we use the hydroxide ion. Then it means we need the concentration of hydroxide ion produced by a base. So today's lesson, we are actually going to look at how to determine this. This concentration. And today's lesson, we are going to focus mainly on the acids. We have different types of acids. We have monoprotic acids, we have diprotic acids, we have polyprotic acids. Now when we talk about a monoprotic acid, since you know that mono means one or single, when you talk about a monoprotic acid, you are talking about an acid that produces only one hydronium or hydrogen ion. Like for example, HCl, HF. This acid will only produce one hydrogen ion when dissolved in water. So it means when we calculate the pH, we are going to take the exact production of hydronium or hydrogen ion to this equation. Same goes as this hydrofluoric acid only produces one hydrogen ion. Now I know by now, or for now it doesn't make sense, but let us look at another types of acids. We have diprotic. Di means two. Diprotic acid simply means that they produce two hydrogen ion when dissolved in water or when it takes place in a titration. For example, H2SO4. This will produce two hydrogen ion. So let's say during stoichiometric calculations, you calculate the concentration of sulfuric acid, and then you find that it's 2 mole per dm cube. This is the concentration of sulfuric acid. So if you want to know the pH of the sulfuric acid, which has the concentration of 2 mole per dm cube, you should know that sulfuric acid produces 2 hydrogen ions. So using our stoichiometric equations, we can say H2SO4 will produce 2 of hydronium or hydrogen ion. So it simply means if you want to calculate or use this equation, we are not going to substitute 2, but instead we are going to substitute the ratio of 1:2. 1 of sulfuric acid produces 2 of hydronium or hydrogen ion. So we are going to take this number and multiply it by this 2. So instead of 2, we are going to put 2 multiplied by 2, we are going to put 4 here. Actually, we should write it like this, 4. And then for sulfuric acid, for hydrochloric acid, if we have 3 mole per dm cube using stoichiometric calculations, then it means when we go straight to this equation, we are going to substitute the very same value we have here, because the ratio, it says 1 hydrochloric acid produces 1 hydrogen ion. So all the monoprotic acids, they only produce 1 hydrogen ion. So basically I'm trying to show you how to apply this equation. You need these skills. Now going forward, let us actually look at another type of an acid. We have monoprotic, diprotic, and then we have polyprotic. Polyprotic, it's more than 2. It's polyprotic acids. So this one, an example, is H3PO4, phosphoric acid. This one produces 3 hydrogen ion. So it means you calculate concentration of this phosphoric acid in a solution. You find that you get 3 mole per dm cube, and then you want to calculate the pH. Before you substitute the equation, looking at the stoichiometric equation, it's 1:3. So 1 concentration of phosphoric acid will produce 3 concentration of hydrogen ion. So we are going to take this 3 multiplied by 3, we are going to get 9. Then 9 is the value that you are going to use to substitute in this equation. Now by looking at these molecular formulas of these acids, the reason why we say this is monoprotic, look at the number of hydrogen do we have. Well, it's not always like that, but in most cases it's like this. We have only 1 hydrogen ion, that is why you say it's a monoprotic acid, and it produces only 1. It can donate only 1 hydrogen ion according to Lorentz theory. Also this one can only donate 1, but looking at this one, the diprotic can produce 2. That is why we say it produces 2 hydrogen ions, since it has 2 hydrogen atoms. Looking at the polyprotic, this one can produce 3 because it has 3 atoms of, 3 hydrogen atoms. So this will be useful when we are dealing with stoichiometric calculation, whereby you'll be given a scenario. It might be a titration, and then the question says you must calculate the pH scale of a solution after the process of titration has ended. You should take note what kind of an acid do you have, monoprotic, diprotic, or polyprotic. You find the concentration. Finding the concentration using the stoichiometric calculation. Remember, you'll be using the data which you are given. Then before you use this equation, pH is equal to negative logarithm of hydrogen ion, take note of the type of an acid you have: monoprotic, diprotic, polyprotic. Monoprotic produces 1 hydrogen, diprotic produces 2 hydrogen ions, polyprotic, it depends on the number of hydrogens you have in the molecular formula of an acid. That's it for this lesson video. This is Wahula SJ. Thank you very much.